Welcome to Executives at the Edge, the podcast from Amplify. Each episode features insights from the top network, cloud, and technology executives, giving you key takeaways to help you grow your revenue and bring solutions to market faster. I'm your host, Pascal Menezes. Join me as we explore thought-provoking perspectives from the leaders and changemakers propelling the AI-powered digital economy forward. Well, I'm super excited to have Abilash Menon. He's the CEO and co-founder of MaiaEdge. And today we're cover an incredible amount of really discussions about how networks and AI will evolve and change. And we'll talk about the agentic realm, how it's going to do to networks, and really AI and networks becoming the nervous system for AI. So stay tuned, listen to this episode, it's really fascinating. And with this, Abilash, welcome to Executives at the Edge. And for our listeners, can you tell us a little about yourself and MaiaEdge?
Sure. So my background is that I started at Cisco Systems. I was in the MPLS world. And then as MPLS tapered down to SD-WAN, I joined 120 Technology, and there I was leading the SD-WAN deployment. So it was a great progression. MPLS, again in the big middle, SD-WAN went to the edges, trying to fix the internet, which was going to be the replacement for MPLS. And now, in MaiaEdge, seeing this problem which I saw in SD-WAN, we came out with a team to fix that big middle, which is having this chaos, a beautiful chaos, I would say. We built MaiaEdge to connect what the industry forgot to connect. That's how I would put it. So let me give you the founding story. Before this team were deep in SD-WAN world. And SD-WAN, there was a real breakthrough for the enterprises because it finally gave them intelligent, programmable control over their edges. So left side sorted, great. The right side, the cloud, the applications were getting sorted. But the middle was a disaster, a complete black box. You had two vendors with two completely different answers, and nobody had the visibility or programmability, and the actual connectivity was just chaos, a manual chaos, expensive chaos, and I would say slow chaos. So we looked at it and said, okay, someone has to fix the middle, but not with another overlay or not with another SD-WAN variant, but with actual infrastructure at the interconnection layer between the fiber operators, carriers, and the data centers. So that's what we built. We built the edge infrastructure that sits at those interconnection points. And we are not network as a service. So each of these fiber operators or data centers can use our infrastructure and set up their own network as a service with their circuits or someone else's circuits. Now, suddenly, those isolated islands become a federated fabric, programmable, visible, instant. No rip and replace, no routing complexity. But here's a bigger truth. We didn't just build a product. We have built infrastructure for an era the industry wasn't ready for. And that era is here now, the AI era. So that's what MaiaEdge is doing.
Well, thank you, Abilash. You know, you talked about the AI era. So tell us a little bit about how do you see, why is AI getting a lot of attention? How is networking evolving to support these AI workloads? I'd love to hear your point of view of, you see this AI era in the middle and how you're going to fix it.
Absolutely. So AI just didn't stress the network. It exposed every assumption the industry has built over the 30 years all at once. Now, how so, right? The old model was very simple. Optimize for throughput. Move packets fast. And even internet had best effort delivery, right? Now, that worked when the traffic was dump. And it was, let's say, one directional. You're streaming a movie or you're sending a file and so on and so forth. But AI broke that physics. The network is not a pipe anymore, right? It's like a nervous system. That's what I would call it. It has to sense, it has to route, and it has to react. And that too in real time. And network is becoming the nervous system of the entire AI economy. And right now, that nervous system is running on an infrastructure which is defined for a completely different body. That's how I would put it. And you have two types of AI infrastructure. One is for training, and the other is for inference. So let's talk about that. Training today is still mostly single tenant. What do you mean by that? You have one big company and one massive GPU cluster and one fat pipe, and they lease it for 5 to 7 years. And you have one big pipe going there, everything is done. But that model doesn't scale to the rest of the world. Let's say healthcare wants to train on patient data, or an automotive system wants to train on proprietary sensory data. They're not going to lease this massive GPU clusters. So training starts to distribute. And why is it distributed? Because you have the user, you have the data, and then you have the training cluster. There are 3 different entities involved here. So they are distributed. They're not in the same place. Now, as training starts to distribute, instead of locking up the infrastructure, you want to burst to wherever the capacity is, right? And train when you need, and then release it. And that is where training is moving towards. Now, let's look at inference. Now, inference is a whole another beast. Inference is what all of us are getting through ChatGPTs or clouds of the world, where you're asking a question, you're getting something back, right? So that's real user experience. Inference is already distributed. It's not just coming, it is here. And it's fragmenting very fast, right? It's at the edge, in the co-location, in the data centers. And it needs space, power, and cooling. That's all. So states are now banning data centers from being built. Why? Because it's drawing power. So what do people do? They are very creative and innovative. They create data center in a box. They put power, they put cooling, and the space is the box. And what is missing? Networking is missing. It's distributed. It's ultra distributed. They are either in some parking lot, or they are either floating. I'm not joking. They're actually floating in some of these vessels. And that's where they're trying to build, because they have space there, right? So when this becomes ultra distributed and ultra fragmented, again, there's chaos. All of this needs to talk to each other. So that's not a bandwidth problem. That's a fabric problem. And we didn't have this fabric there before until now. Now, you have these big middle carriers, or like Equinix and Megaports of the world, and that's perfectly fine. But that's not where the data always sits, right? You have that first mile problem. And that's what we can help solve, the first mile problem. And AI inference and AI training workloads are moving towards that first mile problem because of this distributed nature. Does it make sense?
Yeah, thanks. So I think let's recap. There's a bunch of things going on in training. There are data scientists, or people who data model, who are SMEs. They have to get a large amount of data that is really scraped off the internet and it's stored in big storage farms. So there you need RDMA or Ethernet, and that's a large amount of data that goes to a team that's training a model. Okay, so that needs very little packet loss, lots of bandwidth, and that team then trains with the data on a specific use case, specific specialty, and there are many teams across the planet doing that. So then the models, a single model, let's say Gemini or Chat, or they have to be kept up to sync. So as each team is training their little vertical across the planet from different teams across for that foundational models, they basically get synced. And so that's a very different requirement of what it needs from the network. Okay, correct?
Sure. Yes, absolutely. Absolutely.
And I think that is normally being kind of wavelengths today because of foundational models, but we're going to carry Ethernet because we're going to go to smaller, finely tuned models. We saw GSMA just release their telco model, which is finely tuned from one of the big foundational models.
Yes.
So that's one. The second part is a model will start generating stuff when you need to. And they're being mainly stored in regions of the world, not highly distributed to the edge, correct?
Yes.
And that's kind of being, we were generating data. But what you're saying now, inference, is a whole different beast. Because we're seeing inference is going to go more and more to the edges. We're going to see that we have neural processing units, MPUs are coming out everywhere. They'll be on devices. We're going to see models more distributed towards the edges for inference, computer vision models, smart warehouses, all kinds of smart factories, smart cities. All of this means the edge is going to be highly, highly distributed. And that inference means that it has a very different requirement than the training side. So Is that what I'm hearing?
Yes, exactly. The requirements of inference are totally different from that of training. And if you're really going deeper into it, even the chips are different, right? Because for inference, you need more SRAM. So all of these new chips which are coming out, and why Grok was purchased by NVIDIA was also because the SRAM is what you need. And what people are building are programmable SRAMs, right? So that you can put data in it, and that can also be programmed at the same time. Like D-Matrix is one example. So when you do that, and why do you do that? That's because it's totally different. That itself tells you that. The second is the fact that the way inference works is that you don't need these massive GPUs to do that inference, because the inference you're trying to do it with in memory, because there's a pre-compute and load there. So you're doing it pretty much within a cluster of GPUs together, so they can be distributed. So as long as the model is loaded and you're assigning one for inference, they can be distributed. But what people are not thinking about is, because this is coming, the agentic train. So what I mean by the agentic train is that when you have these agents which are running all around, people are just using it obviously in small scale. But imagine each one of your SaaS, which you're built in the cloud, is an agent. And you have to talk to those SaaS elements, and they're distributed. If you do not have the right latency requirements, then you'll have a very bad user experience. You can go throw all the AI you want, but you need that deterministic network connectivity to bring them all together. So that's why AI is totally different, because AI is not something which is sitting there and it can be done like training. Training is like, okay, I don't care. Training can be done whenever I'll get my model, I can use it. AI is affecting the user experience right then, because it follows the users, it follows the data, and it follows the power. The users are the ones getting the experience. Data is what the rack or whatever they are taking to load, and the power is what facilitates that whole inference engine. So when inference fragments, it moves into every corner of the infrastructure landscape, like the containers, the modular facilities, these tankers, and so on and so forth, right? So each in a different facility, and that's what we are seeing. And that's what we are really excited about, because when inference is distributed into these edges, how do you connect them? You cannot have one carrier go to one place, right? It's totally different facility, different operator network, different data center, but you need a common fabric connecting all of that together. So that's the basic difference there.
So at Amplify, we're doing an AI interconnect fabric, because we really see what you're seeing. And it's really the nervous system, as you talked about. The infrastructure becomes the nervous system of AI, as you said. And that's never done before in networking. Networking was never really part of an application. It was just a transport, a pipe. Now, let's go back to this inference side, because I think you make a very good point. The agentic realm has come on massively with OpenClaw. You see it's going crazy. NVIDIA is now embellished it with NemoClaw to put security around it. We're going to see agents all over. I know you can go buy these Vibe toolings and build agents. You can build agents. So, we are at Amplify building the blueprints to build agents for all of our automation aspects. But what we're seeing is that it's not just a user interacting with a prompt to the edges, like what we think with Gen AI today. It's agents working together to solve problems from an intent of a user, and they will work together in swarms, and they will depend on each other. They'll be synchronously blocked while one agent is doing something. So the networks becomes very, very critical. Like you said, the nervous system, like our bodies, is all dependent upon that communication. We see this AI ecosystem being very, very connected. And now this is what MaiaEdge comes in, right? You help interconnect that whole ecosystem. Well, I have to physically connect and match impedances of that underlay. So I have to match a broadband to a MPLS underlay, to a DIA underlay, to a carrier Ethernet underlay, get all of that to be completely classes of services and quality of services correct is really difficult and challenging. So what you do is, I guess, at MaiaEdge, is you put in kind of an overlay that's tuned to AI. Is that correct? Do I have that correct?
Exactly. You're right. So we built hardware infrastructure, which the data centers and operators can put at their edge, keeping their existing networks the same. And irrespective of the transport, like you said, it could be DIA, it could be fiber, it could be 5G, or it could even be satellite to the space. It does not matter. We will let them connect these isolated islands together. And the best part is they can keep their circuits and they can keep their network. And you can now interoperate between the various different networks, which is not owned by you as well. And that's what we give, programmability and visibility. And it is becoming more relevant, like you said, in this AI era, because as the agentic world is coming into play, an example I would say is we were looking at one of our SaaS providers. When we come in, we do authentication. That takes around 40 to 60 milliseconds. I was surprised. And that's because we have to go and make a call to them. Now imagine that in this agentic world, one agent talks to the other agent, talks to the other agent, talks to the other agent. Now, they may not be in your AWS world. They could be fully decentralized, right? And when that happens, the slowest hop is the one which is going to slow you down. So you have to make sure that this nervous system is a very good nervous system and which is for the right body. And when you talk about your standards too, right, when you're defining different standards and you're defining blueprints for different bodies, and that's what's important. You put it for the right body, it'll work. So you can take that, put it for the right body, works. Otherwise, you put it on the wrong body, it's not going to work. Feel like it works. It's a let me hope it works kind of networking. So absolutely right. That's where we come in to bridge this gap.
And you said something very elegant. You are not network as a service, you enable network as a service. Let's talk about that. At Amplify, we've moved all our assets into a network as a service. Why do we still say that? Because we know networks have to be highly automated. Okay, they have to be highly programmable, highly elastic, and they have to be highly interconnected into the ecosystem in an automated way also, not just within their own networks. So we are now looking at, and we'll be launching soon, I'll be working on with all of the members and the leadership on a federation. So let's talk about that, because I think we think that the internet's going to serve us for the AI era. And we know that is okay for consumer applications. It will not do for when all the enterprises of business go to AI and workloads and agents and so on. So there, I see personally that it's going to be a control plane of automation that interconnects the ecosystem. And so a federation will be born, and it could be, initially a bunch of ecosystems that will be federated together, and eventually there'll be one federation like the internet. But it'll be controlled by a control plane that says, I want to connect from here to there. I want this kind of quality. I want that kind of cybersecurity on my AI, blah, blah, blah. And I think that nervous system has a control plane that's monitoring all of that, that's managing all of that, unlike the internet where you just throw a packet in, pack it out, right? And I think what you're saying is when the ecosystem has to come together and connect, then they have to connect in a way that provides all of these constraints or these attributes of quality and so on. And I think what MaiaEdge is saying is you can keep all your transport. We'll build an overlay interconnecting all of the ecosystem together in a federated overlay. Do I have this right?
Exactly. That's exactly right. So in our case, to make this work, I typically say the operators need to do three things. So federation is one of them. I call it federation, automation, and sovereignty. So federation is exactly like you said. You can't solve a distributed problem with one centralized answer. And you have all these providers, which is not just fiber operators or carriers. They have data centers out there too, right? So this is the big middle, fiber operators, carriers, and data centers. How do you talk to each other in a common way? And how do you exchange policies? And how do you not give up control? And that's very important. You do not want to give up control. And that's natural because you want to keep your customers. You want to own your customers. That's federation. Now, automation is important because if you want to federate, you better be automated. Otherwise, you will be left behind because you want to go at software speed, go and automate it, and quickly, instantly federate with your peers, right? So that's a no-brainer. And the third is sovereignty, and this is very important. Now, with the AI era, it's slowly coming up, and people talk about it, but typically they don't pay attention. But sovereignty meaning you have real guarantees of not giving up control. That is, how does the data flow? How is it protected? And who controls it? So these are three things which I would think an operator would need on top of federation, which is federation, automation, and sovereignty. With this, you can have distributed systems talk to each other and also achieve a common goal, which was not possible before because they didn't want to give up control. So that's exactly what you're saying.
Yeah, and I think you bring up a very good point on sovereignty. So a federation doesn't mean like the internet, everybody's connected together. There will be a sense of sovereignty by nation, which will ensure data's not leaving, data staying in that country or in that sovereign era unit, whatever they want to call it. And I think that becomes a very powerful thing. And how do you have policies to ensure that, monitor that, make sure that, because, we're seeing the world geopolitically wise fragmenting into their own little eras of AI, fiefdom of AIs. Now, why are they doing that? Because we all know AI is going to have a massive impact. In my career of 40 plus years, I've never seen going to be a more impactful technology than AI. And we're just we thought it was AI ML, and then it was Gen AI, and now we're seeing the agentic AI is going to have even more impact. So I think all of this is going to be a very interesting time. And I think the real takeaway is networks as we know it will not be the same. They will be a very vastly different network, as what you said. We call it network as a service for AI, so NAS for AI. It's going to have all of that programmable automation, but not only within the network provider, but across the ecosystem.
Yes.
Right. And I think that supply chain will have to be on demand. So we're watched what we release out here shortly about an on-demand supply chain and how that will work. And I think that will plays very much into what you're working on at MaiaEdge. And I think also bolted to that will be guardrails and policies of cybersecurity for AI that has to make sure that nothing goes rogue because everything's fully automated and agents are doing autonomy and they're fully have the capability to self-reason. But how do we know something doesn't go rogue in the whole system, right?
Yes, absolutely.
So I think all of this has to come together, and I think it's a very, very interesting time, and I think it's probably the most fun time in my whole career. And I'm sure for you, Abilash, you've been doing it a long time. I think what you're doing at MaiaEdge is very, very revolutionary and transformative. And I think we're going to see some very cool technologies, but more importantly, innovations. And I think the impact to society come out. Of course, we can use the negative ways, but we want to be optimistic and positive that it's going to have a great impact. So,
absolutely. You're right. Like this is, I always, I'm envious of the children who are growing up at this age because they get to do so much with AI which we could not. I mean, we had to do it the hard way. And now your baseline has gone up and then there's so much more innovation. So people think about, job loss. Job loss will happen because the jobs being lost are the ones who are not being automated. So that the people who are just doing mundane jobs, yes, they'll be lost. But they can go out and start now innovating on top of the baseline. Everyone's baseline has gone up. Now you can be more creative, build more stuff. But when you do that, the exciting part for me, coming from the networking background, is that they have to be connected. Yes, go and do more AI stuff, more connectivity, more problems to solve, more exciting. So that's how I see this whole world. And it's going to change the civilization. People just think about ChatGPT and Claude. That's just enterprise. It is going to completely change the way we live and we interact. And that's the exciting part. When that comes, which is coming in the next few years, you have to have them connected with sovereignty in place, with security in place. So those are the places which we have to really innovate and make sure it is ready for usage. Otherwise, people will not adopt it.
Well, Abilash, we could go on and on forever. This has been exciting. I'm as passionate as you are about this. I think the world is going to see a very, very transformative era. And it's all about, are you willing to adapt? And I know with Vibe tooling, I don't need to code anymore. I can just write, natural language is what I want from a feature set, and the code gets built for me. With OpenClaw, I can build agents. I can give the skill sets of prompts it wants. I give instructions, So I think the world is changing, and I think what you're saying is you got to embrace AI and start using it to increase your productivity and be an innovator, an entrepreneur with it, because you can do that now in all kinds of ways. So with that, thank you, Abilash. It's been a real pleasure having you on this episode.
Thank you so much, Pascal. Thank you so much, Pascal, and thanks for this opportunity. It was great talking to you. Yeah.
Thank you for listening to Executives at the Edge, brought to you by Amplify. Be sure to follow, share, and leave a review. Catch every episode on your favorite platform or visit us at amplify.net.